Hello Nat5, welcome back to this next video. So in this video we're going to be looking at cycloalkanes, the bromine water test for unsaturation, as well as isomers. So isomers are really important and they come up time and time again in this unit, and we're going to introduce them in this video. So firstly, cycloalkanes. These are cyclic molecules, which means that they are in a ring, and they contain only single carbon-carbon bonds like the alkanes do. They're named cyclo, then we've got our prefix, so that would be meth, eth, prop, but, pent, hex, het, or oct, and ends in ane, so cyclo something ane. They've got the general formula CnH2n, which you might recognise as being exactly the same as alkenes. So however many carbons there is, there's twice the number of hydrogens. So let's have a look at the molecular formula, full structural formula, and short structural formula for the first four cycloalkanes. So notice how we start at cyclopropane. We can't have a ring with less than 3 carbons in it. So in the shortened structural formula, we still show the ring. We just don't show the bond to hydrogen explicitly. So we've still got all the bonds in the structural, but we get rid of these in the shortened. And that's how we convert from full to shortened in cycloalkanes. So let's move on to the test for unsaturation. So unsaturated molecules contain carbon-to-carbon double bonds, for example, the alkenes. And saturated molecules have all of their carbons already joined to single bonds. So unsaturated molecules mean that there's space to add something to them. And saturated molecules are full, which means you can't add anything else to them. So if we've got an alkane with bromine, if we shake that test tube, there's no effect on the bromine, it stays the same colour. However, if we've got an alkene with bromine, it decolorizes it very quickly, and it goes from orange or brown to colourless. So, for example, we had cyclohexene, which decolorized bromine water, but it's an alkene. Heptane, which did not, because it's an alkane. Cyclohexane did not. Octwanine did. Hexane did not. And dipentene did. For our exams, we need to be able to identify which types of molecules will decolorize bromine water and which of these will not. And that's just known as a test for unsaturation. We also need to know the colour change that is associated with this. So our conclusion for this experiment was that bromine water can be used to distinguish between an alkane and alkene, because alkenes decolorize bromine water while alkanes do not. And this slide again summarises what we need to know. Unsaturated molecules decolorize bromine water, and it changes from orange to colourless. This word here, colourless, is important. Often I'll see pupils say the word clear. The bromine water is clear in itself, usually we can see through it. The key is that it goes colourless, so that's a really important distinction. So isomers are molecules with the same chemical formula, but different structural formula. So if we look at propene and cyclopropane, these are both C3H6. However, one has a double bond, and one, the carbons are in a ring. So we can tell just looking at them that they're very different molecules. Every alkene has a cycloalkane isomer. So for propene, we've got cyclopropane, butene, it's got cyclobutane, and so on. So butanene, cyclobutane are isomers because they both have C4H8, however the structure is different. There's also one more isomer of butadiene, and that would be butadiene, where we've got the double bond in the middle of the molecule instead of at one of the ends. So these are our three isomers of butadiene. If we look at butane, however, there's two isomers here as well. It's a bit less clear where these come from because butane contains only carbon-carbon single bonds. So if we look at butane, that's our most simplest isomer. All four carbons in a line, all hydrogens are joined. However, if we move one of the carbons so that it looks a bit more of a L shape, or T shape, we get 2-methylpropane. So it's slightly different and another isomer. The larger the hydrocarbon, the more possibilities for isomers you get. So what we could do now is we could try to draw 3 different isomers for pentane. I've got some clues for you. So a straight chain is a good place to start. Isomers cannot be mirror images, so we can't just flip the molecule. And a good hint for getting isomers is to shorten the chain length. Pause the video now and have a go at drawing these isomers. Okay, so we have our just basic pentane with the 5 carbons in a line. Then what we can do is we can add a branch to the second carbon to 2-methylbutane. And the final isomer would be to add 2 branches, and this way we've got a sort of cross section. So we've got our more branch here, then we've got full cross, and this is 2,2-dimethylpropane. In the next video, we'll go into much more detail about how we name these. But for now, we need to know about how isomers look, how they've got the same chemical formula, but different structural formula. So have a go at looking at these 4 images. Again, pause the video now, see if you can identify which pairs are isomers. So number 1, because we've got 4 carbons and 3 carbons, is not an isomer. Number 2, because we've got 4 carbons, one in a T shape and one in a straight line, these are isomers. Number 3, we've got 5 carbons, one is in a T shape and one is a cross, so these are isomers. And number 4 is perhaps the most tricky to identify, because we've got branches going off, both, but these are actually mirror images of each other. So it's actually exactly the same structural formula. These would both have the same name, 2-methylbutane. So these are not isomers. So that's all for this video. Make sure you've got your definitions of isomers down, as well as unsaturation test and cycloalkanes. See you again for the next video.